afternoon and welcome to this Nesta online event, Innovative Solutions to Make Heat Pump Installs Easier. I'm Katie King and I'm a director in Nesta's Sustainable Future mission, where our goal is to reduce household carbon emissions. We know that heat pumps are central to the UK's transition to clean heat. However, the reality right now is the install journey is often more complex than that of a gas boiler. Our recent research maps this user journey and highlights that the process currently has a lot of barriers and frictions, and this stops many motivated householders getting a heat pump. But these barriers are not insurmountable. The government's new Warm Homes Plan sets out an ambition to enable a standard heat pump install to be completed within 3 days of a final quote. So today I'm joined by 6 industry innovators who will each deliver a fast-paced 5-minute pitch on how we can make heat pump adoption easier. Please drop any questions in the chat and we'll cover them at the end. First, I'm going to set the scene with some of the main barriers and a few ideas for improving things before handing over to our innovators. So what are the biggest barriers to heat pump installation? Our research found that for a home to smoothly transition to a heat pump, 3 things need to align: the householder, the building, and the admin. So with householder readiness, consumers obviously need to be aware, motivated, and afford the switch. And currently the psychological effort of navigating the quotes and the unfamiliar technology can cause people to drop out. When it comes to building readiness, this is a controversial one and one that many of our innovators will be tackling in their presentations. And then administrative readiness, we find that about half of homes are affected by the fact they need to get an up-to-date EPC to get the grant. And we welcome the government's recent commitment to remove that. About 10 to 20% are delayed by the need for planning permission, and about 10 to 20% require an upgrade to the grid, a looping or a fuse upgrade, which means they face longer delays waiting for their DNO to approve them. But the good news is all of these barriers can be overcome. So I'm going to talk a bit about some of these admin barriers and the light at the end of the tunnel for those before handing over to our innovators. So I'm going to talk briefly about planning. I think there's a lot that could be done. In the Warm Homes Plan, they state that consumers should be able to install a heat pump in almost all homes without needing to submit a planning application. And to make that a reality, here are some specific reforms that Nesta would like to see. So firstly, expanding permitted development rights. We've got suggestions for how in our latest report, so do look that up. We want to reform the sound standards, this is the sound limit for heat pumps. We've actually commissioned some research alongside MCS Foundation, which will report in the summer on this. We also think that councils could go further to make local development orders or local listed building consent orders, like Chelsea and Kensington have done, where for solar, for windows, they've freed up planning for certain streets and certain areas. And finally, we think the cost should be reduced. We're calling for a lower planning fees for heat pumps across all nations because to recognise the fact there's a public benefit of clean heat, just as fees are waived for disability access adjustments. If we did all of these things, we would drastically reduce the number of heat pump applications required. So I can see that it can happen. And then finally, I'm going to talk a little bit about DNO approval. In the Warm Homes Plan, it targets 80% of DNO applications being approved automatically or within 24 hours. We think there's a few key things. We think there should be a time to approve incentive. So in the new regime from 2028, Ofgem should implement a strict framework for penalties or incentives to encourage DNOs to approve faster. We think that they should incentivize preemptive upgrades, obviously proportionately. And then finally, smarter data sharing. Ofgem and Scottish Government should allow DNOs to access the boiler upgrade scheme or the Home Energy Scotland application data. And this would give the networks early sight of where demand is so they can plan. Again, these are fairly simple changes that could really speed up approvals. So I hope that's essentially whetted your appetite for the rest of our innovators who are going to speak to some of the other barriers. So first up, we've got our speaker, Justin McMullen, Principal Policy Advisor for Consumer Rights at Which. Over to you, Justin.
Thank you. So at Which, over the last few months, we've been looking at how we can support homeowners with older boilers, both to avoid last-minute purchases, but also so that they have the good quality advice at the point where they need to decide how they want to replace their boiler. So the first step we took was some research. I hope this doesn't come as a surprise to people in this audience, but we found that most people don't spend a lot of time thinking about their boilers. Unfortunately, this is also true as their boilers start to get older. So we found that 3/4 of homeowners with older boilers don't have any sort of plan for what they will do when their boiler stops working. And even when their boiler starts to show signs of wear and tear, half of homeowners don't have any particular plans for what they will do when it stops working. So as a result, quite a lot of homeowners find themselves making a last-minute purchase, a sort of distress purchase of a new boiler. Obviously, for a lot of homeowners, that's quite a large unexpected expense. It often happens in winter when you obviously particularly need hot water and heating. And of course, it is particularly inconvenient and stressful, particularly if some members of the household are older or you've got younger children. But it is manageable. We don't want to particularly scaremonger around it. In most cases, you can get a new boiler within 2 or 3 days and you're up and running again. But much more significant, particularly for this group, is it's a massive missed opportunity. This is clearly the point at which consumers are replacing an old boiler is clearly an opportunity to engage them. They're much more likely to want to be engaged. It's much more convenient and sensible for them to make a change, think about their options at this point. But at the moment, as I said, we're missing this opportunity. So when we spoke to consumers who have recently changed their heating, 2/3 of them said that they hadn't received any guidance at all as to what they might do when their old boiler stopped working and they needed to replace it. Most consumers say that their thinking at the moment is that they would just stay with what they know best, so they would probably stay with a gas or an oil boiler. Interestingly, consumers are open to considering a heat pump. And amongst those consumers that did plan ahead, had some time to think about this, if they saw information about a heat pump as part of that research, they were way, way more likely, almost twice as likely to consider a heat pump. But that was quite a small number because most people don't have the opportunity to do their own research. It's very much a last-minute decision. Interestingly, we also found that consumers that did plan ahead tended to spend a little bit more. And this was a surprise to us because we assumed that people that were making a last-minute purchase were in a bit of a rush, had to take what they were given, potentially sort of paying a bit more for it. But when we spoke to installers, they said people that plan ahead were probably getting a few extra pieces of work done. For instance, they might be getting the system flushed, they might be getting heating controls, they might be changing the whole system. So increasing the upfront cost, but potentially saving money in the longer term. So that was something we didn't expect to see, but it did make sense. So what we took from that is that consumers do need a nudge. They need a bit of persuasion to engage with the planning a bit earlier and think about what they might be able to do. So over the last few months, we've been testing different messaging, both through our own communications, but also through research. And very briefly, the messages that come through as most effective were affordability, so anything to help reduce the upfront cost of that purchase, highlighting the tangible risks, so those issues around not having heating, not having hot water, they do motivate people to think ahead and to do some planning. And also just making that decision-making manageable and practical. So any sort of simple, helpful advice that you can give is really welcome. But also we think that messaging needs to be more targeted. So using things like Gas Safe Register, there are obviously issues around that, but if it was possible to use Gas Safe Register to identify older boilers, or using boiler servicing visits as well to engage consumers that have older boilers. That will help. So it's really making the case for using these trigger points. General awareness is great, but we should be doing more to use these trigger points where it's more convenient for consumers to make changes. They're much more likely to be engaged.
Brilliant. Thank you, Justin. And leading perfectly on from that presentation, I'd like to introduce Jo Alsop, co-founder of Warmer. Jo, the floor is yours.
Thank you, Katie. By 2050, around 17 million UK homes will have a heat pump. The technology works, the housing stock is ready, yet only a fraction of households today are willing to consider one, and even fewer go on to install. Why? Because at critical decision moments, households are on their own and under pressure fall back on another boiler. Warmer exists to accelerate heat pump adoption by transforming how heating decisions are made. We do this with two software tools, the Warmer Passport and Boiler Ace. The Passport plans the pathway to a low carbon, low cost home. And Boiler Ace brings the pathway forward by preventing fossil fuel lock-in. Together, they support the heat pump willing and the remaining majority make their next heating system a heat pump. Our first tool, the Warmer Passport, is designed to maximise conversion rates amongst the heat pump willing. Because the problem here isn't persuasion, it's attrition. The heat pump willing are able to tolerate some disruption and stomach upfront costs, but the current system is stacked against them, requiring them to learn, compare and commit inside a labyrinth of sales pipelines. From the outset, it's hard work, confusing and expensive, as homeowners grapple with multiple upfront survey fees, conflicting specifications where one installer says 8 kilowatts and the other says 12, and no clear view of how savings stack up across heat pumps, solar and smart tariffs. Momentum is lost, confidence wobbles, and too often even the most motivated households revert to the familiar, another boiler. The Warmer Passport resets this broken starting point. The Passport is an independent pre-sales home assessment and system blueprint designed to build confidence and consistency in the early stages. Warmer's bespoke 3D survey and software platform creates a digital twin of the home usable by any installer. From this, households receive a room-by-room heat loss calculation, a review of their existing heating system, impartial advice on what to do next, and running cost scenarios spanning multiple technologies. For the first time, they're entering the market with a plan. But the heat pump willing are just a small fraction of the households we need to decarbonise. The real challenge lies with everybody else. And this isn't about whether a heat pump would work, we know it will. It's about willingness. The majority of households haven't been thinking about heat pumps. They may not even be sure what one looks like. They're certainly not emotionally or practically prepared to make that leap. So when the boiler breaks down or a plumber says it's near end of life or they're told parts are no longer available, no amount of heat pump suitability will spur them into action. This is where our second tool comes in, Boiler Ace, providing not yet willing households with an alternative to another decade of fossil fuel lock-in. Boiler Ace is a free digital boiler triage tool that assesses an individual boiler model based on its age, parts availability, and efficiency potential. In minutes, households receive an impartial, model-specific score to give them confidence to retain and maintain. Why is this important? Well, because there is enough remaining lifespan in the UK's boiler stock to carry most homes through to a heat pump at their next heating upgrade. In the UK, we've come to believe boilers last 10 to 15 years max, and we can be advised that they're approaching end of life from as early as 7 or 8 years. Yet 20-year-old boilers have good parts availability, and many insurance providers have no age limit to the boilers they take on contract, and repair costs a third of replacement over a 5-year period. Boiler Ace converts hidden boiler lifespan and trapped budget into a managed transition, giving households time to build confidence in heat pumps while the market matures and installation costs fall. Combined, these tools establish a new pathway to decarbonise heating. The Warmer Passport converts willingness into installation, and Boiler ACE allows time for that willingness to grow. Together, they normalise planning and preparation as the default route to heat pumps.
Brilliant, thank you, Jo. Okay, next up we have Mikey Harper, Data Science Lead at HeatGeek. Mikey, take it away.
Hi, everyone. You stole the first line of my presentation. I was going to introduce myself. So yeah, Mikey, and I'm here to talk today about heating design of heat pumps and why I think the way we're doing it today is one of the biggest barriers to heat pump adoption. When we think about heat pump installations, every journey starts with three main components. Firstly, there's the home, the building physics of that house, the current heating system they have, and where they're trying to get to. There's the homeowner, and each person is different with their own preferences and their own budget. And then third, and most importantly in our minds, is the installer, the person who has to turn both of those things into a design they can quote, sell and install. So bringing these three things together on paper sounds quite easy. And to be fair, there's some brilliant software in the industry which does enable this to happen, creating well-designed systems which have been manually crafted by skilled installers. But it's been a mission of mine and the team at HeatGeek to digitize as much of the journey as possible using the knowledge of industry experts, many of which are on today's call. So from estimates, quotations, design, and actually monitoring heat pumps when they're installed to validate everything from before, digitization to us is key. And heat pump design makes a great opportunity for digitization. Whilst installers are experts in design and crafting a design for a home, the vast number of options for any single home to upgrade to a heat pump means it's mathematically billions of options per home of what upgrades could be done, from radiators, cylinders, heat pump models, flow temperatures, the list goes on. And this is where Zero Disrupt comes in, something we've been developing at HeatGeek. We've developed a tool that can explore the full design space for every home. We can assess the trade-offs of different designs and instantaneously generate costed and itemized designs which could be ordered from a merchant instantly. This allows us to do quite a few cool things, but firstly, it gives optionality to homeowners. It allows designs to be generated which are low efficiency, still providing a saving versus a gas boiler, or high efficiency. And with HeatGeek, we've developed quite a reputation for the higher efficiency designs. Each of these, again, the homeowner has choice. They're able to see the full design and get an instant price for an informed decision. But more importantly than that is the actual algorithm itself is able to find designs which on the surface may seem unintuitive. For example, existing cylinders. These are often condemned instantly by an installer going to site, but you can often get away with keeping the cylinder and then trading off that efficiency drop by replacing further radiators, a design which is less disruptive and also cheaper for a homeowner to get, all while still achieving the same end goal of moving to a heat pump, which is cheaper to run than a gas boiler. In hindsight, such designs might seem intuitive at the surface, but after looking at it, the engineer and the installer will be able to rationalize why that was picked. So while HeatGeek has developed a reputation for training, it's not removing that, it's just changing the way it's applied. And finding such unintuitive designs could be something which would take hours and hours for a heating engineer to do on site, which is clearly not a feasible option for this. So what's the impact? Well, we've already seen a massive reduction, over 30% reduction in cost for heating installs via this. Most homeowners are excited by the lower cost options, but a lot are still going for the higher cost of luxury upgrades, and they're able to understand what is essential and what's actually a choice. Maybe they just want to replace all the radiators themselves anyway. Each heat pump installation is monitored. Again, this is great knowledge from a commercial perspective. We're able to guarantee an install, but from a data perspective, we're able to monitor every installation we get and learn and improve that algorithm. So we're already making refinements to the work to provide more guaranteed and more confidence behind the design that it will provide the efficiency we quote and achieve or continuously bring that price down. So where to next? And I'm rapidly running out of time. Once you introduce algorithmic design, it vastly simplifies the opportunity to bring in further technologies, finance, fabric, batteries, tariff, solar. All of these things in a normal non-algorithmic approach create exponential additional variables to consider, but with an algorithm is suited perfectly to address that. And with the decarbonisation approach, we need to really think in the whole system, not just with the heat pump. So wrapping up, coming back to where I started, the building, the homeowner and the installer. Zero Disrupt gives the homeowner real choice and optionality over luxury and essential upgrades to get a heat pump. Gives installer tooling to make it easy to come up with all the designs needed, and builds full physics simulations of homes to guarantee that those designs will operate as we quote them to be. Hey, thank you. Sorry, slightly over time.
No, thank you. Brilliant, Mikey. Okay, continuing on the theme of simplifying the physical installations, I'm delighted to introduce Luke Hodgkinson, CEO of ADIA Thermal. Over to you, Luke. I don't think we can hear you, Luke, I'm afraid. So we're going to go straight on to Tej.
No, I'm here. Are you? Sorry. Sorry. Is that right? Yeah, so if you've looked into getting a new heat pump, you've probably been told you need new radiators, new pipework, maybe underfloor heating. And as colleagues from Heat Geek or friends from Heat Geek and Which have mentioned, this is because you're working off of not particularly accurate data, and we need to be conservative to make sure people's bills don't go up. But what it means is often it's a renovation before you even get to the heat pump. And that puts a lot of people off. And whilst historically it might have been true, it certainly isn't anymore. And at ADIA over the last 3 years, we found that up to 90% of homes don't actually need a single radiator changed. You can install a heat pump with no more disruption than a gas boiler, and the bills will come out cheaper than gas. And that's even with today's bonkers electricity prices. So it's really good news if you've been thinking about it for a while and you haven't pulled the trigger. And it's great news for the majority of people in the UK that don't think about their heating till it breaks. So I know there's quite a few people here, but for most people, heating isn't sexy, and well over half the boiler sales in this country are distressed or urgent. So someone wakes up on a cold morning with no heating, no hot water, and they need something sorted within 2 or 3 days. It's not the right time to start talking about a renovation. But if you can do a heat pump in the same timeline, suddenly those people have a real choice. And that's what we're doing at ADIA. Just this week, we've had 3 installers finish jobs in under 3 days. And it's easy if you're not ripping up floorboards or replacing radiators. So how does it work? And firstly, why do people think you need to change radiators? Well, it comes down to flow temperature, and that's the temperature of the water going around the radiators. So heat pumps are more efficient at lower flow temperatures than boilers, and lower flow temperatures mean you need bigger radiators to output the same amount of heat. That logic isn't wrong, but it misses 2 levers that ADIA uses that can meaningfully change the equation. So the first is when you run the system. Electricity isn't the same price all day, and if you're on a smart tariff, which you can switch to on the same day if you're with Octopus, it's really easy to change. Overnight rates can be 3 or 4 times cheaper than daytime rates. So a heat pump that's being managed properly can do most of its work during those cheap windows, store heat in the building fabric and in the hot water cylinder, and run less during the day when electricity is expensive. And this changes the economics completely. You can run at much higher flow temperatures with the existing radiators without it costing more than gas, because you're paying so much less for each kilowatt of electricity that you're consuming. And the second thing is balancing of radiators. So in most homes, radiators are sized based on the width of the window, not the heat loss of the room. And so heat isn't spread evenly. Some rooms get too warm, some never quite get warm enough. And this is because some radiators are getting more water flow than others, as well as their sizing. If you've ever tried to balance a heating system manually, you'll know it's a dark art. If you turn the lock shield valves to make one radiator warmer than another, and even the best heating engineers struggle with it, especially on older homes. And even if you get it perfect on day 1, it's a fixed setting. It can't respond to the sun coming through and heating up that room, or cold wind on one side of the house. ADIA Thermal, our heat pump controller, manages both of these levers. So we learn how your home behaves. We learn the heat loss of each room. We learn the thermal mass that's available to preheat it. And we use that to control the flow temperature and shift the heating into the cheap periods so that you spend much less, on average 35% less on your electricity bills or on your heating bills than you would before. And our smart valves automatically and constantly balance the heat across all the rooms in your house in real time, which gives you room by room control. So you can keep your bedrooms cool and your living spaces warmer. It's basically like having a heating engineer living in your house, tweaking things every few minutes throughout the day, keeping you comfortable and warm with a keen eye on your heating bills. There's another important part of the ADIA journey. So if you're starting without making these changes, it doesn't mean that you shouldn't at some point, renovate your heating system. So after a few months of heating, we give every customer a prioritized list of anything that would make the system work even better. Which radiators are the most undersized, which rooms are losing the heat the fastest. That means that you can make an informed decision on your own schedule, not based on a kind of theoretical survey up front with EPC data, but based on real data from your own home. However, the vast majority look at that list and never bother changing anything. The system's already working, which should tell you something about how overstated this renovation question has been in the past. So think about how your boiler works or used to work. You probably never think about it. It comes on, the house gets warm, the bills are what they are. That's what a heat pump should feel like too, and that's what ADIA does. ADIA is available today, so yeah, get in touch if you'd like to learn more. Thanks.
Brilliant, thank you, Luke. And now over to Tej Patel, CEO and co-founder of Remby. Tej, over to you. Thanks,
Katie. Thanks, everyone, for having me. I'm really looking forward to the Q&A actually as well, so thanks to co-presenters. Really brief, I'm going to tell you a bit about Remby and what we do, and one of the areas around of innovation that we do around DNOs. So Remby was formed 3 years ago with a simple goal to help get everybody into a decarbonised home. And we do this by connecting homeowners to a trusted network of high quality installers. And for those installers, we help them accelerate project delivery by reducing bottlenecks in their process from on-site performance estimates and acoustic assessments to grid application, planning application, building control sign-off, through to handover and servicing, all with a sharp eye on consumer protection and quality adherence. And we can offer a leading best-in-class financial protection model through our partners at the IAA, so that we can really stand behind the quality of those installers and the work that they do. And this is a key part of the Warm Homes Plan for those of you that have read it, as well as DNOs. In fact, DNOs are mentioned 16 times in the document because they are a critical enabler of large adoption of low carbon technologies. And for those of you that don't know who DNOs are, they're the grid operators who are basically responsible for ensuring safe supply of electricity into our homes and our properties. And low carbon technologies like heat pumps, EV chargers, solar panels, battery storage are requiring higher levels of electricity demand and generation than we've previously had before, coupled with poor asset data that the DNOs have at individual property level, means that assessments have to be made to ensure that what you're looking to install is safe and doesn't create complexity or harmonics in the grid that then create larger scale disruption. We tackle this in 2 ways. First, we chair working groups with several DNOs with a goal to better understand bottlenecks and constraints for them and other stakeholders in current processes and help them as part of the ED3 framework to get ready for that in 2 years' time, as well as implementing quick wins that we can solve for today. And with that, we also enable some of those into our digital platform to help installers through that application journey. So for example, we can identify from design files the relevant information required for a grid application and send that to the DNOs, reducing the need for complex time wasted looking up equipment specifications. We can find MPAN numbers, we can identify where there might be a potential issue and help them with that. For example, one of the more time-consuming administrative steps, for example, is often where applications are then escalated and there's a lot of backwards and forwards between the individual homeowner and the DNO and the installer. And that could be because there's additional information required. It could be because there's what they're looking to install isn't suitable for that property and they need to make a change to the original design. And that happens actually quite a lot. And that's typically around 60% of all applications end up in this escalation route. And because each DNO operates individually and differently, that journey could be very different. So we've developed an agentic AI tool with the help of Nesta as one of the ways that we help to solve this. And the idea is that that can sit in between that email trail where there's lots of backwards and forwards and help speed up delivery times. So for example, let's say a DNO needs to carry out an electrical assessment on that site or wants the installer to do that. Currently, there'll be an email saying these are the options. You can either proceed with a different equipment specification or carry out this electrical safety test. There's then a response back to say, yes, we would like to go ahead and do that. The DNO then replies back with the actual assessment requirement and the form that needs to be completed, which then makes its way to the installer, usually someone in office, who then has to pass that back on to the site team, coordinating with the homeowner for that assessment to take place. And as you can imagine, that takes days and days in the process. And if you're looking for a particular distressed purchase, that's time you don't have. So what the agentic AI tool can do is actually sit in between that web and automate some of the tasks and steps already so that it can understand if a loop impedance test is required, what the test requirements are, and pass that through to the installers through our mobile application whilst they're on site already, saving days in the process. And our mission is really simple with this. We want to streamline the process for everybody, ensure that compliance stays high, and help the DNOs improve transparency and actually effectively speed up the application times, the auto approval rates for more technology to be adopted, and build up a predictive model where we can then start to look at where local reinforcement work might be needed ahead of time so that we're proactively preparing the grid for large-scale heat pump adoption. So I'll pause there. As I said, I'll try and keep it quick. Looking forward to the questions at the end.
Brilliant, thanks Tej. So our final speaker is Jez Klimas, Head of Business Development for Renewables at City Plumbing. Jez, the floor is yours.
So hi everyone. Now City Plumbing, we're a merchant, so we sell a lot. We sell a hell of a lot of heat pumps. And part of my job is to make sure we're on top of the latest innovations, and if people need them, we've got them, or we're ahead of the curve on supplying them. So I'm just going to do a little mop-up of a bunch of things that are getting better, some of them big, some of them small. I think for a heat pump install to be successful, it needs to be designed right, installed right, commissioned right, and then it needs to be maintained. So there's a whole lifespan here, and we actually have touch points all through that. But the big thing at the moment for me is R290 clearance zones. So heat pumps are switching over from F-gas refrigerants, which have high global warming potentials, to using natural refrigerants, predominantly propane, which is known as R290 when it's a refrigerant in a heat pump. When those first came out, you had to put them a meter away from basically anything. They couldn't be within a meter of openings into the home, ventilated floor void openings, drains, anywhere where the propane could accumulate in a flammable mixture. But the manufacturers are starting to innovate. So Grant are the first one to go, that they now have much smaller clearance zones around their heat pumps, which is fantastic. New Valent products launching this year are all going to have much reduced clearance zones. So that's actually a huge benefit. It just makes it that much easier to design and place the heat pump. So that's really cool. Other interesting stuff we're seeing just little innovations that are small quality of life improvements. So there's a heat pump mover, a company called Lightwork Designs, who are a heat pump installer, made a pretty simple device actually. It's like a little shelf with an axle and some wheels and a strap, but it makes it just so much easier to move a heat pump around site and get it into the right spot, and it takes it from a two-man job into a one-man job, which is a huge benefit for a lot of jobs. Then you've also got heat pump covers. So Alexandra Burton, she's started a heat pump cover business. Just neat little tarpaulin covers that keep heat pumps clean and protected during installation. It's only a little thing, but it makes a huge difference that installers can be a bit more quick around the unit. Controls is a huge thing. Going back a few years, the onboard controls on heat pumps were not great a lot of the time. They were clunky to set up, lots of meaningless settings to enter, and then they were not very user friendly. And that's improving gradually over time. Real things to call out here, I'd say, is Ideal with their Halo controls on the Logic Air. It's the easiest to commission heat pump I've ever seen. It's spectacular. It's just a few button presses and you get good performance of a very small amount of user input. And then Grant have also innovated in this area. Their smart controllers proving very popular, and Samsung have got the new AI controllers. So there's lots of cool stuff happening out of the big manufacturers. But then you're getting even more interesting innovations out of specialist controls companies. So Homely have been around for a little while, but they were first to market really with a controller that really optimizes flow temperature in real time all the time against smart tariffs and against the thermal response of the home. So, the amount of sun coming into a home, the amount of heat being generated internally in the home all actually change how much heat the heat pump really needs to put in there, which full weather comp doesn't account for. So Homely was great for that. And subsequently, I mean, you've heard from Luke, I'm a massive fan of Adia, the fact that their controls give people the room by room control that people kind of expect when they're spending a lot of money on a heating system, but without detriment to the heat pump performance, in fact, enhancing it. So that's all really cool. Love that. Some simple stuff. One thing with boilers, you never had to build a base for a boiler. You hang it on a wall, it's 4 screws. Building a heat pump base is a thing that a lot of installers have done very inefficiently and long-windedly for a long time. Casting a lot of concrete, digging a big hole, any case, on hard landscape, gunning out driveways to then build a concrete base for a heat pump. And it can account for quite a lot of the work on a job. There's cool stuff, telescopic feet now. So you've got existing hard landscape, you can have telescopic heat pump feet. I mean, you can get the heat pump level and stable without doing any digging. So that's huge. And then we're getting increasing traction on prefabricated plastic bases, polar pad. So on soft landscape, you can just scrape away a bit of soil, get that level-ish, put down 50 mil of gravel and just joggle a plastic base in, and you've got a level, stable base on soft landscape. And then the other cool thing, last bit thing I'm going to talk about is, so because the scale we've got to now is that we're in a maturing industry, certain things were expensive on account of small run rates and scarcity. So antifreeze valves and heat pump feet have just been a bit artificially expensive for a while because there's just not been that many people having to bring in a pallet at a time. But now at City Plumbing, we've hit the volume where we're able to, there's no technical innovation here, it's just business. We're now able to bring in large quantities of own brand antifreeze valves and feet, which is knocking a couple £100 off the cost of an install compared to buying branded products for some people. So there's lots and lots of little things which are all chipping away at every little problem in heat pump design and installation that is bringing the cost down, and innovative installers adopting this stuff really are able to make adoption easier for customers.
Brilliant. Thank you, Jez. Right, we've got about 20 minutes for questions. I'll take the first one, which was from Andrew Butt, about who owns the gas safe register, because I know the answer to this. So it's the health and safety executive that control the data, and there has been a movement by an organisation called Ambient to support DESNZ in negotiations to access it. And we know that there's movement there in trying to get access to data, either for government itself or for others. Right, I will move on to some other questions. Right, let's start with Dave asks, how would the percentage affected by DNO approval change if install rates were higher? Is this about upgrading the link from home to the grid or local grid capacity? I'm going to pass this one to Tej.
Yeah, thanks, Katie. And thanks, Dave. Good question. I think two elements to that question, really. If we increase the number of installations without doing anything to proactively make the process standardized across the DNOs, then the risk is that will become a bigger bottleneck. So the simple answer is it will get worse if we don't do anything about it. The other kind of flip side to that is we could also incentivize more people to not tell DNOs about what's being installed, because those bottlenecks go up. So actually they know less about what's being installed and larger scale distribution problems happen. To answer the specific question about what some of the challenges are, it's really a combination. So it could be local reinforcement, which means there could be delooping required at a property, i.e. stopping the supply that goes in being split into 2 different properties. It could be local transformers that need to be upgraded. It could be individual cutouts on the supply that comes into your house that could need to change. Or it could simply be that actually what you're looking to install is absolutely fine, and they're okay with any potential risk because your maximum demand is still relatively low to the capacity in that area. So those are the types of things that come into the decision-making process. I hope I've answered the two parts of that question.
Brilliant, thanks, Tej. Okay, we're going to move on to Chris has a question. What steps can or are being taken to reduce the number of badly designed, installed, commissioned systems and to fix existing ones where occupants might not be able to afford the work themselves or find suitably qualified specialists? I can say a bit about some work that Nesta has been doing with Bristol Council, where we've been auditing some of the installs that they have paid for over the years in council and social housing. And the findings of that will come out in the summer. But we have found that it is quite difficult to get remediation, to find installers that will do remediation, and also that there's there's many reasons why an install hasn't been done correctly, like you say, potentially designed, installed, or commissioned incorrectly. One thing we're interested in, I think it was mentioned by Jez, is things that will do some of the commissioning automatically. So, for example, Homely will take control of the weather curve. I'm interested in if any other speakers have some thoughts on this question.
Well, yeah, Katie. So, so Homely were kind of first to market with it. Passive have subsequently come out with a very similar system with a wall controller as well. I've not personally had experience of that. And then obviously Luke at Adia, their system does a whole lot more in that it takes care of radiator balancing as well and in real time. I think, well, and like I said, Ideal have got automatic weather curve setting built into their own controls that come with their heat pump. So I think, I think in 3 or 4 years' time, I think we'll all laugh that people used to manually set weather compensation curves on heat pumps. I was laughing about it in 2005 because I came from commercial M&E and you don't do it there. I think it's the way it's going with manufacturers' controls and the really cool third-party stuff like Adia.
Definitely. And the thing to say actually is, how do we make sure that whatever replaces eco, that these are built in so that there is monitoring, or that there is like some of the things that the best installs have? How can we make sure that those who get them through grants also get these benefits? I'm going to move on.
Sorry. So just to say, from the sort of individual homeowner's point of view, one of the challenges has been knowing who to contact if something goes wrong, particularly if the installer's gone out of business over a period of time. Hopefully that is going to be tidied up. Some of the reforms that MCS is bringing in will make it much clearer that there is one person. You contact MCS directly. It's not about contacting the consumer code or the standards body or getting passed about between those. You can just contact MCS and they will try and resolve any disputes that you might have around the quality of the install.
Brilliant. Thanks, Justin. Okay, I'm going to move on to, is there any update from HeatGeek on the innovative hot water options? Nano store, ? Mikey, what can you tell us?
No public update. I think there's the Nano store is one of our kind of in R&D solutions at the moment, and I know it's been installed at some test homes to get the data. Essentially, it's kind of like data driven in these to make sure that we know the performance profile from real homes. So I'd say watch this space, watch the YouTube channel. I'm sure there'll be updates on this soon.
Brilliant. I've got another question for you, which is, does zero disrupt not shorten the lifespan of the heat pump through increased compressor starts? I'm not sure that this data and other negative factors are being passed on to the end user.
Yes, so we're very cautious on the heat pumps limits, and we work quite closely with the manufacturers on these. So I think clarifying this, the compressor starts, a zero disrupt install should not result in a change on that. That's coming down to increased compressor starts tend to come down to poor design. These are still designed with short cycling in mind, so we're avoiding short cycling. They may run harder, but again, within the R290 heat pumps available on the market today, well within their operational bounds. and they said we maintain the warranty with Phelan. So it'll be interesting to see. Yeah, I'd love more data. I mean, we're doing everything we can today to make sure the designs are as no detriment to the long-term performance of these systems.
Brilliant, thank you. Okay, on to Ben has a question. Given that high temperature R290 air source heat pumps are still relatively new in public buildings, what are the best operational or maintenance issues you've actually seen emerge after a few years of operation, and how should councils design projects to avoid them? Put your hand up if you have a view on this, and I'll pass it to you. No takers? Jez, there you go.
Well, yeah, so I think the only real thing is, a lot of these public buildings, we're talking about public buildings, have been running hot anyway on boilers. And so the use of R290 heat pumps, or the emergence of R290 heat pumps at commercial scale, which is pretty recent, enables an upgrade of that sort of public building without doing a lot of work on the heating system. The only real thing about longevity, I'd say, is the heat pumps are a little bit more sensitive to fouling. They've got smaller waterways than a lot of commercial boilers. A lot of commercial boilers have very large waterways and heat exchangers. So you just got to make sure your system cleanliness is really good and the water quality is there to make the system cleanliness stay good. But I mean, in commercial M&E, that's mostly taken care of most of the time. I've spent 15 years as an M&E consultant doing commercial buildings, so I've seen a lot of it. It's not. You do get horrendous cases, but for the most part, it's something you can deal with. And if the existing system's really, really filthy and there's nothing you can do about it, like you're hooking onto a bunch of steel pipes and cast iron radiators in a church, then you just have to put in some separation so that you've got a clean system and a dirty system. And then in a really extreme case, you have to kind of duplicate those heat exchangers so you can take one out and thoroughly clean it whilst you run off the other one. So I've done that working on very old Cambridge College heating systems. So there's always ways around it, but in the commercial world gets a lot more murky than domestic world. In domestic world, you can always just replace a thing because it's a small enough system that you can get the problem out. But when you've got a big sprawling building, those costs just balloon if you're talking about fixing existing stuff.
Thanks, Jez. Okay, I've got a very different question here from Andy Sutton. So he's saying that essentially we're all talking about air source heat pumps and at the moment air to water. Someone made that point. We haven't touched on air to air in this conversation, but let's say air to water, we're rolling those out. But there's this alternative future where we could have ambient loops and ground source heat pumps that would rely on local authorities or utilities backed by patient finance, progressively installing these over a long period of time and giving people the chance to connect. What are people's thoughts on this, and are there any levers to prompt longer term thinking? I can say from Nesta's perspective, we're certainly interested in this, and our Clean Heat Neighbourhoods work has very much focused on this. We've been doing some work specifically with Plymouth on how they could look at planning what technology where, and we'll be publishing that shortly. But essentially, we do really think that it would be great if councils were able to look at a regional level, were able to plan and to communicate to people. You might want an individual system, but you actually might be more suitable to be part of one of these other schemes. It's just what the timeframes will be, and it's sometimes hard to get finance for those other types of technologies. I don't know if anyone's got any other. Yeah, Mikey.
I mean, to me, it's the fundamental. If you look at most academic studies, like those approaches do make a lot of sense. To me, it's the challenge of society. I look at my street full of council houses I live on. In the 90s, when they were all owned by one authority, all the windows got updated, and then they sold parts off, and now we're in this private thing. It takes a bigger change than just the heating industry to get to a world in which we're moving back to kind of community assets. So I think as individual innovators, to me, it's always thinking about what's the biggest impact we can have today. So, and it's that small step. So I think the sleepwalking is a good point there, because I'm actively stepping into what change could I make today and targeting individual homeowners with a proposition which lets them get decarbonised today. That's culturally the easiest thing to do. And I said, so it's a bigger societal challenge, I think, which is, I'm glad people like Nesta are looking into, because it's a complex one.
Yeah, I mean, I think the answer is, like, you know, these common law systems do just require a load more trenching. If you're doing it, you know, in a suburban neighbourhood, it requires a load of trenching and digging up that individual heat pumps don't. And so the capital cost is just that much higher. So I think they need to be reserved for cases where doing individual air source heat pumps doesn't work, which could be very high density neighbourhoods, like back-to-back terraced houses where it's really hard to find space for a bunch of heat pumps, and, you know, tower blocks. And in those circumstances, they're absolutely the right thing. But then, yeah, you do a neighbourhood, a street, or a building at a time, and the extra capital cost is fine, because it's, well, it may be the only way through it. I think an interesting thing about tower blocks is just whacking a 2.5 kilowatt split unit on every flat. It upsets people because they don't like the look of them all over the outside of buildings, but we all pretend like you can't electrify the heating of tower blocks. But a quick visit to Seoul will show you that the technology absolutely exists. And not only that, it's produced in eye-watering quantities at low cost.
I think I would just add to that you know, these big infrastructure projects, there's one in Cornwall, wasn't there, announced last week, and they're decades in the making, and heat pumps only have decades of life at best, you know. So I just think that all this stuff needs to run concurrently, and get the cultural kind of swing away from gas into clean energy, and I think this stuff will kind of bubble up in different places. But ultimately, individually, if you can fit a heat pump anytime in the next 10 years, you will be making a significant contribution to carbon reductions, and hopefully, you know, bigger energy savings over time than versus gas boiler.
Absolutely agree. Okay, I've got a question from Stephen. Do you think there should be a national installation standard for heat pumps to provide guidance and managed by BSI? Raise your hand, speakers, if you have thoughts on this one. I know at Nesta we are interested in what could change about the current standards, and how can we avoid, as there's greater rollout, we obviously want people to be having a good experience. They tell other people they've had a great experience, and other people want heat pumps. So
I mean, I would just say this plays into the competency piece, really. What is the competence of engineers today to go and fit heat pumps well? And there's clearly a gap, and there's an acknowledged gap. And the Building Services Regulator has done a lot of work into mandatory competencies for gas engineers and upcoming heat pumps. And I think the standards piece is kind of linked to that. So how do we bring competency up? How do we align it with a standard that is flexible enough to work around manufacturers' instructions? So I guess within the gas industry, we have Gas Safe, which is really just about gas safety of the gas pipe. And then we don't really tend to have too many system skills type competencies, which are so important for heat pumps. So I do think it's really important there is some sort of standard. It needs to be flexible, but it has to be aligned with how we're training new entrants and existing gas and oil installers to fit systems well, whatever they're fitting.
Thanks, Joe. I've seen Andrew's asked how Nesta's Start at Home project is going. I'm just going to put a link to the project in the comments, so you can see. Essentially, this is a project where we are, at its simplest, offering gas engineers a free heat pump to put in their own home, and then in doing so, they can understand the technology and become hopefully an advocate because of the experience they have. And when they're talking to their gas customers, they can say, oh, I've got a heat pump, and talk about it. It's going really well. We've just this week launched a big marketing campaign for it. Please do pass it on to any gas installers that you know. There's now lots of different schemes there. So it's almost underneath that, there are different schemes that essentially umbrella schemes that installers can join to get their free heat pump. But yeah, it's going well. I think we'd love people to spread the word, because we really want to get thousands of installers joining the scheme. Right, what next? So here we go. What's the panel's view on how to scale up deployment rates to get anywhere near net zero targets? Particularly interested in views on Nesta's ideas around area-based programs. What can we do to really speed things up? I mean, obviously make electricity cheaper, but that's something in the government's control and not ours. I wonder if anyone else has any thoughts on scaling things up and getting rapid take up. Yeah, Luke, we'll go for you first, then Mikey.
I mean, I think that the two really important things are the cost and speed to install. The new government targets are exactly correct. If we want to hit government targets, we need to have something that's as affordable and as easy to install as a gas boiler, and that means it needs to go in the 2 to 3 days that you've got when a boiler breaks down for less than £3,000. And I think that, you know, HeatGeek Zero Disrupt is a great way of doing that. With ADIA, any installer can achieve a similar outcome as well. So that's, yeah, for me, I think that's really simple.
Yeah, and I was going to add that I think everyone on this call is talking about innovation. Like, we all have to innovate. The industry requires innovation to get the cost down. If bus goes, you know, this industry doesn't survive in its own sense. So I think it's just been great hearing so many different ways innovation is happening. So,
brilliant. And Justin, you can have the last word.
Yeah, sorry, you go.
Oh, Justin, you're on mute.
Sorry. I'd certainly agree with sort of all the innovations to make installations quicker, better, etc. I would just say, I think at the moment we're running on the early adopters, and if we want to get into the mainstream, we do have to have a really sort of compelling argument around heat pumps will reduce your energy bills, and it will be effective at heating your home. People really need to be convinced about that. And I think we have to be realistic about how unfamiliar this technology is for a lot of people. For a lot of people, it's not something they're going to decide on in a week or so. They'll want a bit of time to get their heads around it, do a bit of research, etc., etc. So we need to start engaging with them earlier, giving them really good information about their options, and then letting them decide, you know, I do want to make the leap, make a change, get a heat pump. Won't be perfect for everyone straight away, but if you engage people much earlier, hopefully more will be able to take that next step.
Brilliant. Thank you, Justin. I'm afraid we're almost out of time, so we'll have to wrap up the discussion there. But I want to say a huge thank you to our brilliant speakers today, Joe, Justin, Mikey, Luke, Tej, and Jez. And a reminder that Nesta has published 2 recent reports on these topics, identifying barriers to air source heat pump adoption and should we be making homes heat pump ready. You can find those both on the Nesta website. Thank you all for joining us and for your excellent questions, and have a great afternoon.